7 fireballs in 20 days. 3 of them dropped recoverable fragments onto populated areas. 1 detonated with the force of 250 tons of TNT, shaking houses across multiple counties. And none of them, not one, belongs to any known meteor shower. That last detail is what makes this genuinely unusual. Every year, Earth passes through well-documented streams of cometary debris on predictable schedules. The Perseids in August, the Geminids in December. These produce meteor activity on cue, and their parent bodies are identified. What's been happening across North America and Europe since the start of March 2026 doesn't correspond to any cataloged source. In this video, we'll go through these sightings one by one, examine the recovered meteorite fragments, and explore a hypothesis that links this entire cluster to something that passed through our solar system just months ago. March 2nd, Louisiana. A bright fireball captured on doorbell cameras and dash cams across the southern part of the state. Bright enough to classify as a fireball, meaning it outshone Venus in apparent magnitude. March 3rd, Washington State. Another fireball just 24 hours later on the opposite side of the country. March 8th, northern Germany. This was a long-duration event. A sustained streak across the sky visible for several seconds. Fragments punched through the roof of a residential house and were recovered almost immediately. This is the first confirmed ground impact of the cluster. March 9th, Pennsylvania. One day after Germany. March 11th, New York, just before midnight. Both classified as fireballs based on brightness. No fragments recovered from either, but both were reported by hundreds of independent witnesses. March 17th, Ohio. This was the largest event in the sequence. The incoming object was estimated at roughly 6 feet across, weighing approximately 7 tons. It exploded in the atmosphere with the energy equivalent of 250 tons of TNT. The sonic boom rattled windows, set off car alarms, and was felt by thousands of people across a wide area. Fragments were located and collected. March 21st, Texas. A smaller object, roughly 1 foot in diameter, about 1 ton in mass. It released energy equivalent to 26 tons of TNT. A live baseball broadcast captured the streak. GOES East satellite instruments registered the atmospheric flash as a plasma discharge, essentially showing up as a lightning strike on orbital sensors. Fragments were recovered from a residential neighborhood. 3 countries, 7 confirmed fireballs, 3 sets of recovered meteorite material, all within a 20-day window, all outside any recognized meteor shower. Here's what stands out about the recovered material. All 3 samples, from Germany, Ohio, and Texas, show the same basic structure. Dark fusion crust on the exterior formed by frictional heating during atmospheric entry. Beneath that crust, a mottled white-gray interior, consistent with a chondritic composition. Chondrites are the most common meteorite type, so visual resemblance alone doesn't confirm a shared origin. Many meteorites from completely unrelated sources look similar to the untrained eye. What's needed is laboratory analysis, oxygen isotope ratios, mineral compositions, trace element profiles, and cosmic ray exposure ages. If those fingerprints match across all 3 samples, it would be strong evidence that they came from the same parent body. That analysis is underway. Preliminary reports suggest the material is an ordinary chondrite, likely H or L type, which narrows the field but doesn't resolve the origin question. If all 3 turn out to be chemically identical, the implication is significant. These aren't random sporadic meteors, they're pieces of the same thing. The International Astronomical Union maintains a catalog of every recognized meteor shower. Each has a defined activity window, a known radiant point in the sky, and in most cases, an identified parent body, usually a comet or asteroid whose orbit intersects Earth's path. March sits in a dead zone. The chondrites wrap up in early January. The lyrids don't begin until mid-April. There is no active shower during the window when all 7 of these fireballs occurred. NASA's formal classification for these events is sporadic background, a catch-all category for meteors not linked to any known stream. 1 or 2 sporadic fireballs per month over the continental United States is within normal variation. 7 in 20 days, 3 producing ground recoverable fragments concentrated in a period with 0 active showers. That is anomalous by any statistical standard. Something is feeding this cluster, and the timing aligns with something very specific. Enjoy deep fact-check space stories? Hit subscribe and activate the notification bell. Otherwise, YouTube will not show you the next videos, and you'll miss what we uncover next. In October and November 2025, an interstellar object designated 3I passed through the inner solar system. It was the 3rd confirmed interstellar visitor ever detected, after Oumuamua in 2017 and Comet Borisov in 2019, and by far the largest and most active of the 3. 3I's trajectory was nearly aligned with the ecliptic plane, only about 5 degrees off the flat disk where all the planets orbit. At perihelion, its closest approach to the Sun, it was traveling at roughly 152,000 miles per hour. The solar radiation flux at that distance was approximately 375 watts per square foot, incomparably greater than the near-zero background of interstellar space. That energy bombardment triggered vigorous outgassing, jets of volatile material erupting from the surface in multiple directions. At least one major jet was observed pointing opposite to the object's velocity vector, an anti-velocity jet. Material ejected in that direction would have been effectively decelerated. If the ejection speed was high enough, those fragments could have lost sufficient kinetic energy to fall into orbits crossing the inner solar system rather than escaping on a hyperbolic trajectory. On top of the outgassing, multiple coronal mass ejections from the Sun impacted 3I during its perihelion transit. Plasma bombardment on an already active surface would have intensified fragmentation and debris production. As of late March 2026, Earth's orbital position is at its closest approach to the trajectory 3I followed through the inner solar system. We are passing through the region of space where debris shed by that object would be most concentrated. The object didn't cross Earth's orbit directly, a fortunate near miss given its size and activity level. But it passed close enough that ejected fragments, particularly those braked by the anti-velocity jet, could have settled into crossing orbits that Earth is now intersecting. If the fireball activity continues through late March and into April, this hypothesis strengthens. If it drops off sharply as Earth moves past the intersection zone, that's equally informative. Either way, the data is accumulating in real time. And there's a less comfortable dimension to this. If we're encountering small fragments, objects measured in inches and feet, there is no guarantee that larger debris isn't present in the same field. The objects detected so far were household scale. The detection threshold for objects entering the atmosphere is low enough that anything significantly bigger might not be spotted until it's already inbound. The meteorite fragments are being analyzed, the fireball reports are being cataloged and cross-referenced, and every clear night, observers across the northern hemisphere are watching with a level of attention unusual for March. If these fireballs share a common origin in 3I debris' trail, we may be documenting something unprecedented. A meteor shower generated not by a comet or an asteroid that orbits our sun, but by material from an interstellar object, something that wandered in from between the stars, shed fragments during its encounter with our solar system, and left pieces behind for Earth to collect months later. The sightings alone don't prove this. The chemical analysis of the recovered material will, but the pattern, the timing, the lack of any associated shower, the concentration during Earth's closest approach to 3I's trajectory is difficult to dismiss. Something unusual is falling through our atmosphere. The evidence is sitting in laboratories right now, and the answer may connect us to something that began its journey long before our solar system existed. Unknown debris is raining down from space, but what's happening above our heads might not be the biggest threat. Right now, we are technically living inside an ice age, and the conditions that could push it into something far worse are already in motion. Watch, we are already in an ice age but something worse could be coming. To see what's next.